Welcome, listeners. This is Sanjog Aul, your host, and the topic for today's conversation is in-memory computing ready for the mainstream? And I have with me Massimo Pezzini. Massimo is the Vice President and Fellow with Gartner Research. Hello, Massimo. Thank you for joining us.
Thank you for inviting me to the show.
So we've heard a lot about in-memory computing lately, and it's become cheaper. And even though it's not a new idea, it hasn't fully hit the mainstream just yet. So we wanted to explore with Massimo what are some of the feasible solutions available, what the market is like, and what has been leading the way with this technology. So the first question for you, Massimo, is what would an industry leader come to expect in a good in-memory computing solution?
Well, at this stage, unfortunately, there isn't such a thing in the sense that the in-memory computing technology space is still quite fragmented. We have identified at least 6 different classes of technology, each and every one specific to certain use cases. But fundamentally, apart from the individual specific attributes that you expect from each and every one of these 6 technology classes, what you want to select as an in-memory computing enabling technology include the ability to plug into your enterprise's established IT environment. In-memory computing doesn't come out of this blue sky. Of course, it needs to be integrated into your existing IT environment. It must be able to support standards. What you're looking for is technology which is supported by the industry. Skills availability is an issue in in-memory computing, and therefore you want to buy a technology for which there is an available set of services and offerings from system integrators and so on. You want to select a technology which is supported by third parties, for example, independent software vendors and system integrators and so on. And of course, cost is an issue. There is a perception in the industry that the IMC is expensive. This is not necessarily the case. IMC doesn't necessarily need to cost a fortune.
So what problems do you think it's expected to solve? What are we expecting for it to solve for an organization? And how do you think it's going to affect their day-to-day business?
Well, generally speaking, scale and insight. There are business processes for which time is very critical. Think about, for example, financial trading, right? The difference between making millions of dollars or losing millions of dollars is a matter of microseconds, right? So anytime you have a speed problem, IMC can be very helpful. Scale is another type of issue. For example, in global businesses like, e-commerce, for example, or global online gaming. Speed is important, but even more important is the ability to serve hundreds of thousands, if not millions, if not tens of millions of users utilizing your systems. And IMC can really help a lot in this respect. And finally is insight. Of course, in-memory computing is about processing data very quickly. Let's say several orders of magnitude faster than by using traditional thinning disk type of technologies. And this gives you an opportunity to analyze a lot of data in a very short period of time. You can run business intelligence reports that will take hours using a traditional technology in seconds. And this gives you, of course, an unprecedented level of detail into your business, and this helps you collecting insights that will be almost impossible to do with traditional technologies.
So for those who actually have begun to adopt in-memory to their organization, how encouraging have the results been? And what are the type of problems that they are facing or not facing? And because there's a lot of hype that this is going to cause problem or not going to cause problem.
Well, of course, this is a technology, it is software, it's hardware, and I'm not aware of any hardware and software which is not causing problems, right? So there are indeed problems. But in terms of benefits, we have both incremental and transformative benefits that organizations can experience through in-memory computing technology. For example, we are seeing organizations running their business intelligence reports in a fraction of the time it will take them to process using traditional technology. One episode is an energy company here in Europe. Using traditional technology, it will take them something like 12 hours to populate their data warehouse to create a whole bunch of reports that their users they need every day in order to plan operations for retail and other types of processes. By using in-memory computing technology, they've been able to reduce this time from 12 hours to 2 hours, meaning that now, people, when they get to the office, they have their reports available and they can start working immediately. But we also see transformative utilization of in-memory computing. Another great example which I have is a bank in Sweden. It's called Avanza Bank. This company, they have rebuilt completely from scratch their core banking system and trading system. So let me repeat, core banking system and trade system on top of any memory architecture. And this is giving them a lot of benefits from a business point of view. For example, now they are able to release new products and services to their customers in a matter of literally few days. They release a new version of their application every 8 working days, for example. It is the use of in-memory computing has helped them solving once and for all the scalability problem. Now they can run an incredible amount of transactions per second that would be impossible to run using their previous architecture. And finally, it is helping them introduce product innovation. For example, they are able to calculate the risk profile of their customers in real time, allowing them to offer to the client terms very specialized, very specific, and very customized terms and conditions. And this is helping them winning a new client. They are gaining several thousands of new clients every week because of this innovation they have introduced.
So would you say, in summary, would you say for the most part it is meeting or exceeding expectations, or there are some specific areas where it is not?
Well, the problems associated with in-memory computing is that it's not plug and play, right? The vendor rhetoric suggests that you just replace your traditional database with in-memory computing technology, and all of a sudden, automatically, the application will run at 1,000 times faster. That's not really the case. In many cases, by simply swapping out traditional technology and replacing it with in-memory, you see marginal improvements, in some cases no improvements at all. This is because most of the time, you need to actually rework and adjust your application to take full advantage of in-memory computing technology. As I was already saying earlier, skills is an issue. So you can even buy the best in-memory computing technology in the planet, but if you don't have enough skills, if you don't have the experience and the expertise, and if you cannot find anybody helping you, the benefits are simply not going to happen. Monitoring and management of any memory computing environment is challenging. Think about you may have hundreds of servers storing your data in memory, and managing what's going on is really a challenge. So I would say that from a business point of view, from a business benefit point of view, most of the cases I have seen organizations actually meeting their business goals, but not as easily and cheaply as they would expect.
So in terms of the marketplace, what do you see? What is a specific need which it is driven by? Would you say for the most part, whosoever wants to use big data as an area of innovation and or real-time analytics, they are the best or the most profiting users or companies using in-memory computing?
Well, for sure, big data and analytics and real-time analytics are powerful drivers for IMC. As we said, we have seen organizations dramatically improving the performance of their business intelligence applications by leveraging memory computing. But we do see quite a lot of use of in-memory also for transaction processing applications. For example, e-commerce. For example, travel reservation. For example, online gaming. Internet banking, online trading. Those are all transaction processing applications which are benefiting a lot from the use of in-memory computing. Algorithmic trading is an industry that wouldn't exist without in-memory, very much like, for example, cloud. Cloud software as a service are very much enabled by in-memory computing. But I believe the breakthrough innovation driven by in-memory will come from what we call hybrid transactional analytical processing. So the ability to inject real-time business intelligence, real-time analytics, predictive analytics in the context of transactional business processes. For example, in the context of, an order to cash process, the ability to run what-if analysis against the live data and not against 1 week old or 1 month old data to decide whether to push in the order in sending to the client certain products or other products on the basis of considerations such as customer satisfaction or profitability. Those are all things that are enabled by IMC and that will for sure create a breakthrough innovation in the industry.
What do you think would be a strong vendor solution, and what kind of attributes do you think the buyer should look for? And in today's day and age, or basically as a current state, do you think the vendor solutions that are available, they are really feasible and are ready to be fully utilized or ready to create the full value that anyone would look for?
Well, there is an assumption in the industry that in-memory computing is an immature technology. This is not really the case. In-memory has been around for 10 plus years. Some products, they came to the market in the late 90s, right? So technical maturity is not really an issue. What is an issue is more the ability of the vendors to translate the theoretical benefits of in-memory into concrete business benefits on a project-by-project basis, on a vertical-by-vertical basis, on a process-by-process basis. The skills problem, which we already alluded, and the technical fragmentation. Today, it is difficult sometimes to understand whether the best fit for a specific problem is an in-memory data grid, an in-memory database, or a complex event processing technology. So those are, I would say, the challenges that customers are facing. But from a technology maturity perspective, I believe that there are a lot of products out there which are ready for prime time.
Let's take a quick break, listeners. We'll be right back and explore how is it being integrated, this new in-memory computing solution set being integrated into the whole suite of business functions as opposed to becoming just another piece in the IT toolbox. Please stay tuned. We'll be right back.
HP is proud to sponsor this program. Find out how the HP as a service solution for SAP HANA can help you gain instant, impactful business results without capital investment by logging on to hp.com. Transform information into intelligence and a competitive advantage with a full spectrum of SAP HANA products and services from HP, a global SAP hosting partner. You are listening to CIO Talk Radio Analyst Corner.
Welcome back. So, Massimo, how is it being integrated, this in-memory computing solution set being integrated into the whole suite of business functions, as opposed to being or becoming just another piece in the IT toolbox?
Well, today is primarily yet another piece in the toolbox, but we do see packaged application vendors more and more integrated in memory computing in their offering. In some segments, for example, the supply chain management, you have in the market already a good number of packaged applications which are natively taking advantage of in-memory to offer superior capabilities and innovation to their customers. E-commerce is another area where we do see a lot of in-memory technology being used by vendors. Call center operations is another one. And the most important, I would say, software vendors are working as we speak in order to integrate in-memory computing technology in areas like financials, HR, CRM, and other horizontal type of solutions. So today, for the most part, organizations which want to leverage in-memory computing need to, let's say, build their own custom solutions on top of in-memory. But I will say that over the next 3 to 5 years, a large proportion of packaged application solutions will be natively built on top of a memory computing platform.
So I know in the past, or I mean, even recently, people were saying that DRAM was basically one of the showstoppers where the cost of DRAM was so high that people were not adopting it to the degree you would have expected. Is that all been taken care of, or do you think we are beyond that part now?
Well, I would say that definitely the cost of DRAM technology was an obstacle up until, let's say, 5 or 6 years ago. And undoubtedly, the ever-dropping cost of any other technologies, specifically DRAM, for sure is an enabler for memory computing. But there are a few other aspects that need to be taken into consideration. Well, first and foremost, in-memory computing technology is quite complex. It's rocket science technology. It took quite a long time to be fully rounded and to mature to the point of becoming digestible, let's say, by mainstream organizations. And moreover, as it often happened, IMC was for quite some time a solution looking for a problem. In other words, the theoretical benefits were clear. They had to do with speed, scale, insight, etc. But it took a while for the industry to find out the killer applications for IMC. We mentioned a few of them already, like supply chain management and supply chain planning, business intelligence, e-commerce, and so on and so forth. But this process of identifying the killer applications for in-memory is still in progress. And we are going to see a lot of innovation in this space. But by the way, we believe that in-memory is going to be a disruptive force in the package application business. So we are going to see a lot of changes, possibly new vendors emerging because of that. And finally, there is another factor, which is that up until recently, IMC was a too small market to be of any interest for the large software powerhouses, right? So only small companies had in-memory computing technology in the market, and of course they had very little marketing dollars to be spent in order to educate the market. And those are all factors which are going away as the large vendors are entering the market, as technology mature, etc. So people like SAP, HP, Microsoft, IBM, Oracle, and others are now fully committed to IMC. So this means that the marketing dollars for educating the market are now available. So the situation is going to change quite rapidly. I would say that IMC is, for the most part, ready for prime time.
So in terms of standards, do you think I know originally when it started, or like any other technology starts, there are no specific standards that everybody adheres to, and it becomes a market share creation game? Do you think we are beyond that as well, and now we are coming to one set of standards which is driving how innovation or evolution is happening in IMC?
No, we are far from there. You are absolutely 100% correct. Lack of standard is a problem, and it is one of the main obstacles to IMC adoption. Very little standards, and even more importantly, as we were saying, product categories and classes, they overlap partially. So sometimes it's really very hard for customers to really figure out which piece of technology they really need and which they don't. Moreover, lack of standards is not only an impediment to adoption on the part of user organization, but also on the part of independent software vendors, software as a service, and service providers investments, which is, of course, a problem. There are a couple of standardization efforts going on, but they are very minor. They address only small portions of the overall IMC architecture. However, there is a good news from this point of view in the sense that IMC technologies are more and more incorporating pre-IMC standards, very popular standards like SQL, for example, or REST, or JDBC and JPA, which is going to make the transition from additional technology to memory, both from a skills perspective and an application perspective, a bit easier. For example, in many cases, we have seen organizations being able to migrate their pre-existing established applications to IMC through the utilization of the standards. However, I believe it's going to take another 3 to 5 years for the technology convergence to occur and for a set of IMC standard to emerge. If I had to point to the main obstacle to IMC adoption, I would say definitely skills, and number 2, lack of standards. No questions about that.
So in terms of the servers and blades which were not being built exclusively for in-memory computing, as we know, does that pose any challenge to the organizations, or just because you now said that we are taking pre-in-memory standards, are they also being adopted for the hardware as well?
Well, I would say so far it is not an obstacle at all, in the sense that we see organizations using commodity servers simply to run their IMC applications. In some cases, there are issues associated with the disaster recovery, high availability, which need to be addressed by the hardware vendors. But this is not really a showstopper. It's only making things a little bit more complicated. However, I believe that over the next few years, we are going to see radical changes also in the hardware architectures. We are beginning to see hardware vendors designing hardware platforms specifically for supporting IMC technology. This is going to help further reducing the cost, and is going to help improving the manageability and the IT operations of the in-memory computing architectures. Consider that today, in order to deploy an application holding maybe, a couple of terabytes of data in memory, which is pretty common nowadays, you need to lay down maybe, 100 of servers, which creates, of course, a lot of IT operation issues. So with new form factors and new hardware architectures, this is going to be reduced dramatically and make everybody's lives easier from an IT operation standpoint.
Are there any specific industries that you think are better suited, or this is going to become ubiquitous?
Well, traditionally, telecommunications, financial service, and the web industry, or the internet industry, if you want, have been the pioneers in in-memory computing technology, right? Because they have very special type of problems. Speed in many of these industries is critical. For example, both in telco and in financial services, scale is critical. For example, in the web industry and in telcos. And moreover, those type of organizations, they typically have the skills and the resources to invest in new technology. So they have been, if you want, debugging this technology for several years, but it is now ready for mainstream. Travel and transportation, for example, is the industry widely adopting this type of technology. Retail is another industry which is investing quite significantly in memory, energy, utilities, manufacturing. So we are beginning to see the use of this type of technology pretty much across the board. But I believe that when in-memory computing-enabled packaged application solutions such as ERP, CRM, etc. will hit the market, this technology will become ubiquitous. For example, if your competitor is able to replan each supply chain in a matter of seconds and it takes you hours, then you have a problem from a competitive standpoint. You are very likely to jump on in-memory to regain, dynamically change pricing of their product in a real-time fashion. And instead, you are only able to change your prices once per day, then you have a competitive problem. So you are likely to jump into in-memory computing as well. So I would say that in the 5 to 10 years now, in-memory will be everywhere. And to a certain extent, this is already the case because people using Facebook or Twitter or this type of social networking environment are already using in-memory computing. They don't know because it's hidden under the covers, but these type of applications, these type of systems are fundamentally enabled by in-memory.
So how is this in-memory computing paradigm expected to evolve in your view? And what do you think would be your advice in terms of what due diligence they should perform as industry leaders or what preparation they should do for their organization so that they are able to make the most use of this exciting new technology?
It is a very fundamental question. Thanks for asking it. Well, in terms of how the technology is going to evolve, clearly the Moore's law will continue to work, so we expect further dropping in the cost of core technology. For example, historically, the DRAM, the production cost for DRAM has been dropping by something like 30% every 18 months, and we don't see any sign that this is going to slow down. So you can expect it. The core in-memory technology will continue to drop. From a more software point of view, I think that we are going to see a convergence of these many different types of technologies, in-memory databases, in-memory data grid, complex event processing platforms, in-memory analytics, and so on, to converge into what we call the unified in-memory computing platform. And this is going to be good for the industry by reducing technology fragmentation and probably pushing towards a cohesive set of standards. We are going to see commodity IMC-specific hardware platforms, as you were saying earlier. Those trends that we definitely believe are going to take place over the next few years. In terms of recommendations for industry leaders, my first recommendation is don't wait. There is no reason for you to wait another 3 years to jump into in-memory. There are very specific low-hanging fruits that you can take advantage of in order to experiment with in-memory computing, understand what are the business and technical benefits, and also drawbacks, of course, associated with IMC, and to start building your skill. But considering IMC only as an incremental technology providing incremental benefit, that will be a mistake. As we discussed during this conversation, IMC is potentially transformative. So a very important thing that the industry leaders should do is to brainstorm with their leaders of their companies, trying to figure out how the speed, scale, and insight enabled by IMC can help their companies build the differentiation and competitive advantage.
Once again, thank you so much, Massimo, for sharing your thoughts and insights on our Viewpoint segment.
And thank you for having me in the show.
Thank you so much again. And listeners, I invite you to find more conversations about in-memory computing as part of our series at www.ciotalkradio.com/in-memory computing.